Hello everyone and a very warm welcome to my channel. In today's video, you will learn that how to create a two-dimensional polar plot in Matlab. That is a powerful and visually appealing way to represent angular data in polar coordinates. So whether you are working on engineering simulations, navigation systems, or just exploring Matlab plotting tools, this tutorial will give you the foundation you need. So we will cover everything from settling up the angle and radius values to plotting in polar coordinates using Matlab built-in function. Plus, we will use a real-world example based on radio antenna signal strength, where signal strength varies by angle. So let's get started. So we need to work on editors. So we are clicking on new script. So an editor window pop up in front of us. So we need to start our code by writing CLC, clear all and close all. After that, we need to define an angle in radian from 0 to 2 pi. So we need to define angle in radian from 0 to 2 pi. Theta is equals to linspace, and we are starting from 0 ending at 2 static pi, and we want to divide the range into 100 equal parts. After that, I'm going to define the radius value based on the real world pattern that we are using an antenna signal. So I simply add my comment here that define radius values based on a real world pattern. For example, antenna signal. Here I am using a real world problem of antenna signals. So radius is equals to absolute, and inside of the absolute we have sine, and inside of the sine we have 2 theta, and outside we have steric cos of theta. After that, we need to create a polar plot. So for that, I am using a built-in function polar plot, that is a two-dimensional polar plot. Inside we have theta and our radius, and I am setting my line width to 2. You can adjust according to your requirement. After that, I am defining my title. So we have dimensional polar plot of signal strength pattern. After that, I am using my I am setting my radius limit, so that is totally optional. So we can simply write it optional customization. You can skip it if you are not interested in that. So for setting the radius limit, I am using a built-in function rlim, and inside I have to set the limit from 0 to 1. So that is basically to set radius limit. Okay, let's run it. Okay, so this is a polar plot that displays that how the signal strength changes as the function of the direction. So function of the direction represented by the theta, and the signal strength is represented by radius r. So the result is a lobe pattern, which is common in antenna radiation diagrams and radar systems. So each point on the plot represents the direction and its corresponding magnitude. So the symmetry of the plot reflects the angular pattern of the signal gain. Secondly, the peak in the plot indicates the direction of the strong signal output. And thirdly, these dip shows where the signal is weaker. So this visualization helps engineers and scientists design and evaluate directional behavior in real world systems. So that's it. If you found this helpful, hit the like button, subscribe, and share this video with your classmates. Drop a comment below if you have any questions. So thank you so much for tuning in. I'll see you soon in the next video. Stay blessed.